In section 7.4, we'll review how to use trig to solve for sides and angles, and we'll take a look at what's called an angle of elevation and an angle of depression. So first, a warm-up, solve for x, y, and z. So in our first problem, we have a right triangle, and we know two sides of a right triangle. So since we know two sides of a right triangle, one way to solve is Pythagorean theorem. So don't forget, if you do know two sides, you can use Pythagorean theorem if you want the third side. And Pythagorean theorem is a squared plus b squared equals c squared. And the legs are the two shorter sides connected to the 90. So we'll have x squared plus 6 squared equals our hypotenuse, which is the longest side, 10 squared. And then we can solve this algebraically. So let's change colors. We have x squared plus 36 equals 100. We can subtract 36 from each side. And we get x squared equals, let's see, that would be 964. And then to get rid of the squared, we could square root each side. So we have x equals 8. And if you remember in geometry learning about Pythagorean triples, 6, 8, 10 is always a right triangle. So there it is. Our side is 8. We can find a missing side of a right triangle by using Pythagorean theorem if we know two sides. So if we take a look at our next problem, solve for y, we have an angle and we have two sides. So Pythagorean theorem is out for this one because you need to know at least two sides to solve for a missing side in Pythagorean theorem, and we only know one side. So that would indicate we're going to use trig to solve. So to use trig, we will select our reference angle. Here it's 71. And y is the hypotenuse, it's the longest side, and 12 is opposite of 71. And if you remember the acronym SOHCAHTOA, we look for the ratio that has opposite and hypotenuse, and that would be sine. So to write this up, we would say sine of our angle, which is 71, equals the opposite over the hypotenuse, which is y. So there's our ratio. And then if you're solving for a side, you're gonna cross multiply. So I'll stick the sine of 71 over 1. We'll cross multiply. We'll get 12 equals, and we'll cross over the other way. And it's y times the sine of 71. And to get rid of the sine of 71, we just have to divide, since it's being multiplied, we'll divide each side by the sine of 71. And then we can type that into our calculator. If you're using Desmos, again, you might have to put it into degree mode. So let me just pop up Desmos here. And to change the mode, you will click on the little wrench tool, graph settings, and change it to degree mode, and then we should be able to type it in. And I'm typing in 12 divided by sine of 71, and we can see that that missing side, y, is about 12.7 is what I'll round to the nearest tenth there. So 12.7, there we go. And there's y, so 12.7, and you can see it is bigger than the legs, slightly bigger than this original leg here. All right, so there it is, 12.7 is y. All right, our last warm-up problem, solve for z, which is an angle. It's on the inside of a triangle. Pythagorean theorem doesn't help you with an angle, so again, we have to use sine to solve. So there's z, and we're going to label our sides. We have the hypotenuse, which is 10, and 6 is adjacent to the angle z. So if we have a and h, that's going to be cosine. So we're going to say cosine of our angle z equals the adjacent side over the hypotenuse. And to get rid of cosine, because we want just z by itself, we're going to do the cosine inverse. So we have z equals the cosine inverse of 6 over 10. And then we just type that into our calculator. So again, if you could figure out the trig function and you're solving for an angle, to get rid of the trig function, you just do the inverse of that function. So on Desmos, you can either type in cosine to the -1 power, or there is a button here on Desmos. If we go to calculator, functions, and there's some trig functions here, and we're looking for cosine inverse. So there's another way to get that, and it's 6 over 10. And we can see our angle is 53.1. So we'll put that in here. Whoopsies. Whoopsies. Let me pop that back up here. All right, sorry, it's taking a second to load. Here we go. And again, we're solving for the angle. We type that in, and we got z equals, was it 53? I can't remember now. 53.1 degrees. I think the assignments on Delta Math have been saying round to the nearest degree, so I'll round to the nearest degree for that one, about 53 degrees. All right, so we've done an example of each, Pythagorean theorem, solving for a side using trig, and solving for an angle using trig. And so today really is day one of review. We will review also on Thursday too, before your test on Friday, your quiz. It's going to be a smaller test. But before we do that, there's some vocabulary that goes with this section, and one of the terms is called angle of elevation. And the angle of elevation is always measured from the ground up. It's the upward angle from a horizontal line, and it's always inside the triangle. You can think of the angle of elevation in relation to the movement of your eyes. You're looking straight ahead. If you're looking straight ahead, you have to elevate. You must raise your eyes to see the top of the tree. So elevate, going up. Angle of elevation is going up from the horizontal. So here's the horizontal line. Here's your angle looking up. There's also the angle of depression, and you can kind of guess what that angle will be. In the angle of depression, let's say you're at the lighthouse and you're looking at the horizon, but then you look down. So the angle of elevation, you look up from the horizontal line. Angle of depression, you look down from a horizontal line. So if we take a look at it, one thing a common mistake, the angle of elevation is not this angle. It's not the purple angle, because you have to be starting out by looking straight ahead first and then looking down. So it's going to be the blue arrow, or that X value there. That'll be your angle of elevation. Or depression, I'm sorry, angle of depression. So if you remember from geometry, the angle of elevation and the angle of depression, they're actually congruent. So here's the angle of elevation from the horizontal looking up, the angle of depression from the horizontal looking down. And again, if you recall from geometry, if you have two lines that are parallel and you have this transversal, the alternate interior angles, if you've learned the Z thing right here, the alternate interior angles are congruent. So really, you can use either angle, the one from the horizontal line down or the one from the horizontal line up, and it's the same angle. So let's take a look at how will you see this in the problems that you have. So here's the first example. We'll do 4 of these. All right, so first example, to see the top of a building 1,000 feet away. Okay, so here's this building. It's 1,000 feet away. You look up at a 24-degree angle. Okay, so we're looking up to the top of the building. Again, the angle of elevation is from the horizontal line up, so there's the 24 degrees. How tall, or what is the height of the building? So we'll call that X right here. Okay, so there's our lovely drawing. It is a right triangle, so we can use trig. The first step is to select your angle and label your sides. So here's our angle 24. Again, you can't use the right angle. You could use the 24 or the other acute angle. We're going to label our sides. We have the opposite side. We have the adjacent side. And if you remember SOHCAHTOA, we're looking for which one has O and A, and that would be tangent. So here's how we set it up. Tangent of our angle equals opposite over adjacent. And if it's solving for a side, the outside, we're going to cross, multiply, and solve. So we have tangent of 24 over 1 equals x over 1,000. We'll cross multiply. We get x equals, we'll cross the other way, 1,000 tangent of 24. Okay, and then you type that into your calculator. Again, make sure you're in degree mode, and you just type it in. 1,000 tan 24, and that'll give us the height of the building, which in this case is about 445 feet tall. Okay, so x is about 445 feet tall. Okay, let's try another one. Number 2, from the top of a lighthouse 210 feet high. Okay, so here's my lighthouse, 210 feet high. The angle of depression of a boat is about 27 degrees. So here's my boat. It's in the water. We'll make it in the water here. Okay, and then the angle of depression. Here's the horizontal line, and we're looking down at the boat. Okay, so here's the angle x, which if I'm drawing my picture, I can do it 2 ways. So either I can make this into a rectangle. Again, the building's 210 feet high, and we want to figure out, what do we want? The distance from the boat to the foot of the lighthouse, so we want this distance at the bottom right here. But remember, this angle and this angle are the same. Ooh, and that angle's 27 degrees. So I'm going to put my 27 here, but it's also this angle right here, this 27. Too much going on here. So we're going to look at this triangle. Here's the 27 degrees. I'm going to look at this triangle. So again, angle of elevation is the same as angle of depression. There's my angle 27. Let's label our sides. The 210 is opposite my angle. So here's the opposite. The x is adjacent. So again, tangent, right? O and A. So tangent, we know the angle is 27 equals opposite over adjacent. So here's the setup. And then again, it's a side that we want. We want the distance from the bottom of the lighthouse to the bottom to the boat. So it's the outside of the triangle side. So we're going to cross multiply and solve. We'll get 210 equals x times the tangent of 27. And our goal here is to get x, the distance from the foot of the lighthouse to the boat. And to get rid of the tangent of 27, it's just a number being multiplied. We'll divide by tangent of 27. So this will cancel, and we get x equals 210 divided by tangent of 27. We can type that into our calculator. So 210 divided by tangent of 27, and we can see that the lighthouse is about 412 feet away from the boat, so the foot of the lighthouse. So x is about 412 feet away from the lighthouse. Okay, let's take a look at two more examples of angle of elevation and angle of depression. Oh, it's just one more example. No, it's two more. It's two more. Sorry. Okay. So number 3, I guess I wrote in the spot, so I was confused. All right, suppose a tree 50 feet high casts a shadow that's 60 feet long. Okay, so let's draw our tree here. So here's my tree, and it's 50 feet high. 50 here. It casts a shadow that's 60 feet long. What is the angle of elevation from the end of the shadow to the top of the tree? So here's our angle of elevation from the horizontal line up. We'll call it x. Let's label our side. So if x is my reference angle, again, here's our right angle. 50 is opposite. 60 is adjacent. Ooh, we're using tangent quite a bit today. So this is tangent of our angle equals opposite over adjacent. And here we have tangent of x, and we want to get rid of the tangent. To get rid of tangent, we do the inverse. So x equals tangent inverse of 50 over 60. And then we just type that in. So tangent inverse, so we can use the function key. Tangent inverse, or you can type in tangent to the power of -1. And it's 50 over 60. And we can see our angle of elevation is about 39.8 degrees. Okay, so x right here, 39.8 degrees, and that is this distance that we're looking up right here, 39.8 degrees. Okay, last example. An airplane is flying at a height of 2 miles above the ground. Okay, so let's make our little airplane here. Okay, so there's my airplane. And it's 2 miles above the ground, so 2 miles. The distance along the ground from the airplane to the airport is 5 miles. What is the angle of depression from the airplane to the ground? Okay, so angle of depression. Here's the horizontal line, and we're looking down. So I want this angle, but it's also this angle down here. So again, if we have our angle of depression, it's the same as the angle of elevation. So I'm actually going to use this triangle down here, which is a right triangle. All right, so if x is my angle, let's label the sides. Again, opposite, adjacent. Ooh, I should have made more examples that were not tangent, but alas. It is tangent again. So tangent of x equals opposite over adjacent. Again, it's an angle this time. And to solve for an angle, to get rid of the tangent, we do the inverse. So x will be the tangent inverse of 2 over 5. And then we just type that into our calculator. Tangent inverse of 2 over 5. And we will get our angle 21.8 degrees. That's the angle of elevation and depression. So x is about 21.8 degrees. All right, so your assignment will be to finish the rest of the Desmos. And if you're in class, these are the same problems as that are on the Desmos. But if you're in class, if you're on Zoom, you'll finish this Desmos that we started with the notes.